Okay, so this is a quick lesson on arithmetic series and geometric series. So an arithmetic series is when you add together all of the terms in an arithmetic sequence. So if my arithmetic sequence is 1, 2, 3, my arithmetic series would be 1 plus 2 plus 3. Okay, so a series is when we add together all of the terms of a sequence. We have a formula. Okay, it looks like this. So it uses all of the same variables as the formula for arithmetic sequence, except that instead of looking for Tn, we're looking for Sn. So now we're looking for the sum. So if we're looking for an example, or for example, this sequence has 3 numbers, so in the series, it would be the sum of the first 3 numbers, so this would be S3. Okay, so the other variables are the same. N is how many terms we're adding together, so in this case it would be 3. Okay, A is the first term, in this case it would be 1, and D is the common difference, which in this case would also be 1. So it's the same variables from the sequence formula, but rearranged in a different way to find a series. For geometric series, it's the same thing, except that now it's the sum of the first n terms in a geometric sequence instead of an arithmetic sequence. And in our general formula, just like for geometric sequence, we still have A, our first term, we still have n, the number of terms in the series, and we have our common ratio r. So our formula here, the only tricky part is that number of terms, the n, is in the exponent, and then here we're subtracting 1 from r to the n. Okay, we'll do an example using the formula. So in our first example, we have Gus working for 35 years. Okay, he's starting at $10,000 and he's receiving $500 extra every year he works there. And he wants to figure out how much money he's going to get in total over his career. So we're adding together each of his yearly salaries, which means we're trying to find the series, right? The sum of all of his money. Okay, we have to figure out if we're going to use the arithmetic formula or the geometric formula. Because he's adding on the same amount every year, we know it's arithmetic. So because he's adding $500 each year, it's our arithmetic series. Okay, which means we need to use our arithmetic series formula. So we have our S, our A, our N, and our D. So Sn is what we're looking for. We're looking for the total amount of money. A is our starting amount, which is $10,000. N is how many terms we're going to add together. So in this case, he's working for 35 years. So we want to add together 35 years worth of salaries. And our common difference is $500. So what we need to do is we need to substitute all of the variables into our formula and come up with his total amount of money over 35 years. So what you should do is you should simplify this and put it into your calculator and just double check that we're getting the same answer. Okay, so just make sure when you're simplifying you're using BEDMAS. So you want to do everything in the brackets here first and then add them together. Then multiply by 35 and divide by 2. So if we simplify everything inside the brackets, multiply by 35 and divide by 2, you should be getting $647,000. Sorry, $647,500. Okay, so over the course of 35 years, Gus Gus will receive $647,500. Okay, so we'll write a therefore statement. Okay, one more example. Okay, so here's an example of another series. Okay, so we have an accountant and she is collecting money bi-weekly, which means every 2 weeks. So if you're collecting money every 2 weeks, that means you're collecting money $26 times a year. Okay, so if you're getting paid bi-weekly, you're getting 26 paychecks a year. And she's calculating that her first paycheck she got $450, her next one was $540, her next one was $648. So we can see pretty clearly from looking at it that it's not increasing by the same amount every time, which means it's probably a geometric sequence. So what you want to do is you want to check to see if it has a consistent ratio between all of the terms. Right, so in order to check the ratio, you do 540 divided by 450. Okay, and you'll do 648 divided by 540, just to check if they all have the same common ratio before you continue on with the question. So if we divide these numbers, we find that they all have a common ratio of 1.2. Okay, which means we're dealing with a geometric series. So as long as her income continues to grow in this pattern, how much would she have made in a total at the end of 1 year? So if she continues to have a common ratio of 1.2, how much money would she make in total after 26 pay periods? Right? Because she's getting paid every other week. So we need to figure out the series for 26 terms for Penny's amount of money. So what we want to do is write down all of our variables. So we're looking for how much money in total. We know that her starting amount of money is $450. That's her first paycheck. We know that the common ratio is 1.2. And we know that we want her to calculate it for the 26 pay periods, so we're calculating it for the first 26 terms. Okay, so if we're talking about her weekly paychecks, we would use 52, but because it's bi-weekly, we're using 26, so every other week. Okay, so now we can substitute all of these variables into our formula and calculate her total amount of money over the year. Okay, so we can substitute in all of the values. So we're looking for the sum of the first 26 terms, starting with $450. Our ratio is 1.2, and our exponent is our end value, so 26. And then we're subtracting 1 from that whole bracket, or from the whole 1.2 to the 26. And once you've simplified the top, you're going to divide everything by 1.2 subtract 1. Okay, so I said before you should be trying this on your own on your calculator to make sure you're getting the same answers. So if we substitute all of this in to our calculator, we end up with $255,319.78. Okay, so the total of all of her paychecks for the entire year is $255,319.78. The takeaway for the series note is that you use the series formula when you're trying to calculate a total amount, and you have to make sure you're using the correct formula. So make sure you know if it's geometric or arithmetic. Once you know, you just substitute in the variables and use the formula.